Good morning, everyone. So today we're going to talk about magnetism and its characteristics. So I'm going to leave this up here just so you guys can kind of listen to me talk as you're writing. So I think it's going to be a little bit faster. So magnetism and characteristics is what we're talking about, right? And I'm just going to highlight some stuff as we're going through this. Um, that way you all can kind of see what I'm talking about, right? So let's start first with what makes a magnet. So what makes a magnet, right? A magnetic domain is what actually makes a magnet. So what is a magnetic domain? It's an area, right, in a special metal that has aligned electrons, right? So that is what a magnetic domain is. Now, special metals, right? These special metals, right? What we're talking about is iron, nickel, and cobalt. So iron, nickel, and cobalt, those three things, those three metals are the only three metals that can actually create magnetic domains. It's something to do with how they're structured. It's the actual nucleus of that atom allows for electrons to actually spin in the same direction. Now, what I mean by that is that electrons are actually moving within the metal, and they all move in the same direction. So what if we have an aligned magnet, right? What if we had an aligned magnet, which is ultimately a piece of metal where all of these domains are pointing in the same direction? What happens is you create this diagram here, right? So this diagram, what it's showing is all of those little arrows, they're showing electrons that are actually moving in the same direction. Now, they're moving up and down, right? That's what this is showing, up and down, up and down, up and down. So what that causes is it causes the top of this magnet, right? If you look at the top of this magnet, it causes it to have a north pole and the bottom part of this magnet to actually have a south pole. And that's how you create a magnet, right? Is by aligning those domains. Now, if you have a non-aligned piece of metal, right, what happens is you create these randomized domains. So each of these little sections that you see here, like this little section here, this little section here, all of these sections, right? Notice their arrows are not aligned, right? So their arrows are pointing in different directions. What that causes is just a chunk of metal. It doesn't have any magnetic properties at all. Now you can temporarily align those metals. If you bring a strong magnet next to this, it's actually going to attract to it. They temporarily align with the magnet, but as itself, it's not an actual magnet. So when you create a magnet, right, what happens when you create a magnet? Well, what happens is you have these poles, right? So you create a north pole and a south pole. Now, north poles produce field lines that point out of the pole. So that's a key point here, right? They're pointing out of the pole. So if you look at this diagram, the north pole, this north pole has arrows, right? Look at all these arrows on the left. All of those arrows are pointing out of the North Pole, right? And then the South Pole has arrows that point into the pole. So this is very similar to like a positive charge. Remember those positive charges that we had previously? All of the field, for, force field lines are pointing out of the positive charge and into the negative charge. So very similar to here with magnetism, right? So you have force field lines that point out of the North Pole and force field lines that point into the South Pole. So what that does, right, and I'm just going to highlight the key points here, into and out to, right? What that does is it, right, allows for these magnets, right? It allows them to kind of create some interactions. So we can have magnets that both attract and repel, right? A magnet can do both, depending on the scenario it's in. So if you have a north and south pole next to each other, what you're going to cause is you're going to cause some kind of, I didn't write this down, but some kind of attraction, right? So you'll create some kind of attraction, and this is the diagram that comes out of it. So you have the force field lines coming out of the North Pole, right, and entering the actual South Pole, right? So notice how those force field lines go from the north to the south. So when you have a north and north pole together, or like two like poles, that's what this is trying to say. So two like poles, right? A north and north, or a south and south. What happens is um, you actually have a interaction with these force field lines that depend on the pole. So let's say we have two north poles. So what we would have is we would have this repulsion. So there is some repulsion happening, right? But the lines are pointing out of the north poles. If you had a south and south pole interacting, what would happen is you still have the repulsion, right? The lines look like they're pushing off of each other. However, the arrows are pointing into the south poles, right? And that's really it. So two like poles, right? If you have two like poles, like north-north or south-south, right? You're going to have this repulsion that's happening. Um, but the arrows will point in different directions depending on the poles. Okay, so that's a permanent magnet, right? So permanent magnets, ultimately, it's because of these domains, right? The magnetic domains that we can create permanent magnets. Meaning, as long as these metals are aligned, these electrons are moving in the same direction within the metal, then we have a permanent magnet. Now we can create temporary magnets, right? So this section here is showing you how to create a temporary magnet. So electromagnets is what we call a temporary magnet. So electromagnet. So an electromagnet is a temporary magnet that uses current to create electricity. Okay. Now there's three major components to an electromagnet. So if you look at the electromagnet, there's three things that we really need. One of them is current. Okay. So here we need electricity running through a wire, right? To ultimately create some kind of magnetism. So the basis of magnetism is, right, the movement of electrons. So we can have, if electrons are moving in a wire, you create magnetism. If electrons are moving within some metal, you create magnetism, right? So notice permanent magnets, the electrons moving within the metal, that's what causes the magnetism. Here, the electrons moving in this coiled wire, that's what's creating the magnetism. So we need current, right? That's like the main thing that you need. So current, is ultimately, right? Remember, this is a term that we use for the flow of electrons that come through a battery, right? Now, if we have uh, if we have a lot of flow, right, larger currents will produce larger electrons. Sorry, not larger electrons, larger magnetism. Great. So that's the first thing that you need. The second thing that you need, right, is you do need an iron core. Okay. So to strengthen an iron core, right, you need, notice that metal, right? There's a nail right through the middle, right? So that nail, iron cores strengthen the electromagnet because it aligns domains in the iron core. Right. So it temporarily aligns those domains in the iron core and it makes it stronger. So that is the main two things that you need. Now the third thing that you need is just coiled wire. So when we talk about coiled wire, the more loops you have, right, the more the current is interacting with the actual iron